Welcome to a presentation on Angels Don't Play This Harp, based on the book by the same name, published by Earth Pulse Press. What we're here to talk about is a ground-based Star Wars weapon system that's being operated in the state of Alaska in a remote location called Gakona. The project is an interesting project. We'll cover the various aspects that the military has disclosed, the University of Alaska has disclosed, and we'll also talk about a number of the applications that they've kept hidden from the public view. But first, a little bit of background on me. My name is Nick Begich. I have a doctorate in complementary medicines from the Open International University for Complementary Medicines in Sri Lanka. And I also have a political background, having been involved in the Alaska Federation of Teachers in Alaska, serving as president for 2 terms, and the Anchorage Council of Education, also serving as president for 2 terms. My family has been politically involved in the state for a couple of generations. My father served in the state Senate. He also served in the United States Congress in the 92nd Congress in the early 70s. The project itself was an interesting one, and one that we really weren't looking for. I think the project was more or less looking for us. The project is a jointly managed project by the Air Force and Navy, being worked in conjunction with the Geophysical Institute, which is part of the University of Alaska system. This project was initially started, actually, the work leading up to it in the middle 80s, and eventually in the early 90s the project was kicked off with an initial funding level by the federal government of approximately $30 million. The project covers a number of military applications that's being characterized by the military, however, as strictly a research project, which is interesting in and of itself. The way they characterize the project as a research project, HAARP, High Frequency Active Auroral Research Project, they've made indication that what we're really talking about is a project to study the aurora. But the project goes far beyond study of the aurora in terms of its applications. In fact, it's more or less a misnomer to suggest that this is strictly about auroral research. It could be like characterizing, in many respects, the Manhattan Project, which brought us the atom bomb, as being strictly a research project, not ever leading, of course, to a weapon system, which we all know is not the case at all. What HAARP is a very large transmitting system. It's a system designed to generate a great deal of radio frequency energy. The way that energy is created, first of all, is by electrical energy going into an apparatus that's been designed by the military. It then goes into an antenna array, and we can look at a few slides of that array just to give a general idea of what specifically we're talking about. The array itself is an antenna field, which is a large configuration. It's not just a simple radio transmitter as such. It's more than that. It's a field of antennas that work in conjunction with one another. And just to kind of flip through the slides just a bit so you get an idea of what these look like. The array itself is pretty large. It covers, at this point, a number of acres. And as it expands, as the site expands, it'll expand to covering many, many, many times more acres in terms of this field. The antennas themselves are fired sequentially in order to get a focusing capacity, which we'll discuss as we go on with the presentation today. But basically what we're talking about is something much different than just a standard radio transmitter. In fact, many aspects of the project itself has been characterized as an open science project, and yet when you look at some of the early stages of the project, you see some things that sort of don't run consistent with that particular thought. When you look back at the original postings on the property itself that the military posted, and the prime spokesman for the project being John Heckscher, he lays out a large amount of the information in a way that people can understand, but at the same time in a complex way in which many word games are played. When we first launched the book itself and started talking about the project openly, the first thing that happened was the signs came down. These are the standard signage that's up on military installations, warning people that if in fact that you violate the perimeters, that you're in violation of the National Security Act. Being an open project, as military has characterized it, And when we started challenging that characterization, they quickly removed these signs. They then initiated an open house, invited everyone in to look at the project to see that there was nothing so sinister there. But it's kind of interesting. It would be like the average person looking at a intercontinental ballistic missile carrying a nuclear warhead. What are you going to see from the outside shell? So they basically took the shell down, took the perimeter signs down, and gave a little higher visibility to the project in terms of the public. This project was interesting in the way it began. It began with the ideas of a particular inventor, Bernard Eastland. And Bernard was hired by ARCO Power Technologies. Actually, the company that hired him originally was Atlantic Richfield, which is the parent of ARCO Power Technologies. And around his ideas, they built this subsidiary. And the subsidiary's role was to find a place, a way, to burn natural gas on the North Slope of Alaska and bring that gas into a marketable form. Currently, Alaska produces approximately 1.5 million barrels of oil a day from the North Slope of Alaska. We do not have a gas line constructed yet, and the primary owners of the gas that's on the slope, which involve trillions of cubic feet of natural gas, is ARCO, Atlantic Richfield, and another company, British Petroleum. So ARCO was looking for this way, some way to consume this power, and they hired Bernard, and they said, Bernard, we want a way to develop a market for this gas even without a pipeline. Is there something we might be able to do? And the conclusions for Bernard were, really there might be. There was a vision in his mind of a weapon system that might be applied to this particular use, and it required a large amount of energy. But not only did it require a large amount of energy, it also required a very specific location, and that location is the closest that they could get where large supplies of natural gas would be available to the place where magnetic lines of force intersect the Earth, which just so happens to fit the bill for the North Slope of Alaska. So Bernard began working on a series of patents. And the first patent dealt with the idea of focusing energy in a very unique way, different from any other radio frequency transmitter previously designed. And when we look at what he envisioned, when you think about radio frequency energy coming off of an antenna, normally what you can visualize can be shown as energy going up and the energy getting less and less dense as it moves higher and higher in elevation. And this depicts more or less the way traditional radio frequency transmitters work. The area they're trying to affect is the ionosphere, which is located approximately 32 to 620 miles above the Earth. So it's a high area, it's a high level. What Bernard did is develop an antenna field concept, which used, instead of one antenna, it used an array, which is what we have at HAARP. And by firing that array in a unique way, by sequencing the firing, they're able to focus the energy to a very narrow point in the ionosphere. What's important here is when you talk about radio frequency energy and when you talk about the way energy is focused, the old technologies, the technologies that the military often references when talking about ionospheric heaters, which is what they term these huge transmitters, they talk about the energy, in some instances, the energy going into the antenna array, which is interesting. They also sometimes talk about the energy coming off of the antenna array at the ground, but never do they really talk about the amount of energy concentrated or focused in the ionosphere.